Hey there, space weather enthusiasts. It's me, Dan, a.k.a. Smash-A-Mash, coming at you from the Smash News Network, least busted name in news, bringing you the most detailed space weather and comprehensive imagery of the sun you'll find in the known universe. You may have noticed on yesterday's video, we forecasted a coronal mass ejection. We largely stopped doing that a couple years ago because it wasn't getting us any views on YouTube. How ridiculous is that? Well, it's pretty ridiculous indeed. We'll talk about it here in a moment. The best news is that the Brian Keating filament is still partially on the sun. Part of it's flying through the solar system, and another part of it is now up here to the northwest of where it initially was. You might be able to see that filamentary reorganization happening there and coronal mass ejection in the southeastern limb. We've also got a bunch of new sunspots, one new one there in the southeast. A setting sunspot in the northwest is the most likely place to see a large flare, perhaps even an X-class event. There's certainly potential there in terms of magnetic field, complexity, and its proximity to the limb. Once again, if you like coronal mass ejection, solar flares, space weather, and sunspots, then you've come to the right place. So that was 171 angstroms. Here is the 304 angstroms. You may be able to see the filamentary ejection and reorganization better in that wavelength. We'll let that play through here once. Pardon the echo. And we've got a close-up of that area, so let's zoom in on that. The Brian Keating filament, folks. Yeah, we've been naming filaments after living people. And since that one was about to become prominent, we thought it was appropriate to name it after Dr. Brian Keating. So here's a close-up of that area. And there it goes. So part of it went to the northwest and part of it went to the southeast, out into space. So a little CME forecast for you there. It's not something that we do a lot. Keep in mind, folks, you don't need solar flares or even sunspots to see coronal mass ejections. And by the way, of course, we did indeed stream that. It happened pretty promptly there. And there it is on the GO 16 SUVI yesterday. Pay attention to the time and date stamps if you want to create your own videos depicting that CME. It's a CME and it's a plasma reorganization really happening there at the same time. And again, that filament is now still hanging out there to the northwest of that new sunspot that just rose in the southeast. Anyway, here's the past. That's yesterday plus today. SDO continuum. Another new sunspot again rose in the southeast. It looks like we do have a new sunspot spontaneously forming right up here in the northwest. Also one down here, not far from the equator in the southwest. So we'll have at least 3 new named sunspot groups today. If you were concerned about the sun shutting down, well, you can suspend those concerns because there's absolutely no chance of that occurring. If you keep forecasting things that aren't coming true and all of the data is contrary to your hypothesis, please abandon that hypothesis as it is most likely not reality. There's your colorized magnetogram, and indeed, there are quite a few magnetically complex regions. We've seen an uptick in the radio flux here. Let's take a brief look at what's going on planet Earth. Starting with volcanoes, so Sakurajima is erupting. And oh yeah, I can move my mouse. That's good. Sakurajima is erupting, producing a 7,000-foot plume of volcanic ash. Subanose-jima, 5,000-foot ash plume, flight level 050. Papendayan in West Java, showing some sulfur dioxide emissions, high-pressured fumarole emissions. So perhaps a significant eruption is fixing to happen there. Popocatépetl exploding, flight level 200. It's a 20,000-foot ash plume over central Mexico. Headed down to Central America, Fuego in Guatemala exploding, flight level 150. Flight level 190 over Sangay as Sangay explodes. So also effusive eruption happening there, lava spilling into the southeast ravine, keeping the flow active as new real estate shows up in Ecuador. Also Revenador exploding, flight level 150. And Cotopaxi, the third volcano in Ecuador. I guess it's probably the best place to go if you're going on a volcanic vacation. As you can see, 3 active volcanoes in the nation of Ecuador. Cotopaxi has dispersed its volcanic ash. Please don't pole vault the caldera. It's still 100% active. Sabancaya exploding, flight level 240. It's a 24,000-foot ash plume over Peru. And let's take a look at seismicity. And while we don't claim to forecast earthquakes, you'll notice the largest quake of the past 24 was inside the triangle that we drew on yesterday's map. Anyway, current level of seismicity is high. That's a 90-day bar graph. Largest quake of the past 24 was this 6.4 near Vanuatu. And that's a location of that. We'll zoom out to show you where Vanuatu is. There you go. That's 6.5 actually came in at 1804 Universal Time yesterday evening. So we're going to scroll up the list and cite quakes over a 5 magnitude here. And it looks like there is indeed an aftershock at Vanuatu at a 5.4 magnitude. Also, Solomon Islands area had a 5.0, not too far from the Vanuatu quake. And also another 5.0 at Vanuatu. So that's the most seismically active region of the planet right now, northeast of Australia. Also, the South Sandwich Islands had a 5.2, 5.0 in Indonesia, 5.3 at Vanuatu, another aftershock there. And what do we have here? A 5.2 in near the coast of southern Peru. Also, Turkey had a 5.0. South Sandwich Islands had a 5.6. Papua New Guinea had a 5.2. And once again, folks, keep in mind any of these earthquakes could be foreshocks. So, once again, I mean, this area right here, quite seismically active. Don't be surprised to see a larger quake there, because any earthquake can be a foreshock. And on that note, let's get back to space. Space, a frontier. These are the voyages of the SDO in 335 angstroms. And we don't always show that wavelength, but it is a good wavelength for seeing solar flares. And since we had 2 M-class events, I believe 2 M-class events, both from the northwestern limb, we're showing 335 angstroms. And we have seen an increase in the 10.7 centimeter radial flux. We'll get to it here in a moment. First, take a moment to press like and subscribe if you enjoy the content. Thanks for tuning in. Congratulations on realizing the channel exists. And thanks to our YouTube audience for tolerating the pathetic, putrid, and disgusting censorship on the YouTube platform. Press the notification bell and make sure you consider becoming a member of the Smash Team. So the Smash Team site, smashomash.com/Smash Team, is the official subscription services site of the channel. And if you want to support us, consider becoming a gold or silver member. The gold and silver memberships start at $2.99. That's the silver level. It's $2.99 a month. The gold level will afford you all kinds of things, like the ability to read into our paper about the mechanism underlying the solar sunspot cycles before it even reaches preprint. So you can read about the theory about that, as well as get your own @smashomash.com email address. So if you'd like something like, like Dan at smashomash.com, that's still not taken. So a gold membership also gets you that. It's $9.99 a month. The best value is the annual paid-up gold subscription, thanks to our Smash Team members. Thanks for increasing the probability these videos will continue to exist, remain publicly visible, and free for all to view. And let's get back to the space weather data. Yes. 10.7 centimeter radial flux now is up to 169 solar flux units. So reaching that crucial 170 mark that lots of people talked about right here and said, hey, we're not going to get above 170. It's just going to come back down, and then we're at solar maximum at 170. What about those forecasts, folks? What about those forecasts? All those grand solar minimum enthusiasts, their mouths are shut about the sunspot number and the 10.7 centimeter radial flux, and they're leaning on one science paper, which has been thoroughly disproven in the past about year and a half. Anyway, that's the 1-year graph of the 10.7 centimeter radial flux depicted by the black line near the top. The red line below that is the sunspot number. The pink line is the 30-day Wolf number. That's the average sunspot number. And then you've got the blue line down there. That's the Potsdam AP, the interplanetary magnetic field. So we do have NOAA forecasting some geomagnetic unrest or minor geomagnetic storm conditions here in 2 days. So on Sunday, March 5th, there early in the day, they're forecasting for some geomagnetic storm conditions from a coronal hole high-speed stream. I think they might be a little early on that, but we are expecting to see some sort of a coronal hole high-speed stream impact around then. We're just not expecting the high-speed portion until a little later in the day. So we may see the density uptick there early on March 5th, but perhaps not the velocity increase until later in the day. So we'll have to see what happens there. Coronal hole high-speed streams sometimes do show up a little bit earlier or later than expected. So it's not really that big of a deal. KP index currently at just pushing geomagnetic unrest conditions here at 3.67 protons per cubic centimeter. We do have an elevated solar wind from another coronal hole high-speed stream, apparently. We'll get to it here in a moment. First, we'll show the last 4 hours of Earth's magnetic moment from space. So this is our Geospace Magnetosphere movie. If you're new to the channel, we show this daily, and this depicts nanopascals, which is magnetohydrodynamic pressure. It is based on the space weather modeling framework, and if you want to read about what that is, click the Details tab down toward the bottom of the page, and you'll find a link to the space weather modeling framework. You can download all the software and analyze it yourself to your heart's desire. So here's ground magnetic perturbations. We showed you Earth's magnetic moment from space. Here's Earth's magnetic moment from the ground. Also, the last 4 hours, it'll show you the most likely places to see induction to power grids, railways, pipelines, those sorts of things. Also, bridges can get some induced electricity. And it'll also show you the most likely places to see the aurora. So again, that's the last 4 hours Earth's magnetic moment from the ground, depicting nanotesla magnetic flux density. Next, we'll head out to Lagrangian Point 1, the location of the ACE and Discover spacecraft, which are measuring the solar wind out there outside Earth's magnetosphere. And here's the current situation. And we've got a very low density solar wind here at less than 1 proton per cubic centimeter there, showing 0.67 protons per cubic centimeter. Solar wind velocity here pushing 600 kilometers per second. So a significantly elevated solar wind speed and a very diffuse density there. Less than 1 proton per cubic centimeter, generating error bars down there. So maybe we'll see the spacecraft switch. At the moment, we're only viewing the Discover, as evidenced by this blue line down at the bottom. Continuing on to magnetic data, there are our GOES magnetometers. They are inside Earth's magnetosphere at a geosynchronous near equatorial orbit. And we're seeing kind of low levels there of kind of low highs and low lows for the GOES magnetometers. And we did see some maneuvering there also. So those GOES 16 and GOES 18 satellites there using their thrusters there to create those arc jet moments. Those can cause abnormalities because those engines produce plasma, which can affect the magnetometer readings. And let's move on to the heliospheric current sheet. So there is a sector boundary headed this way. And I'm thinking that the sunspot in the southern hemisphere is going to be quite a big sunspot because, well, over the years, and we're pushing 6 years on making these daily space weather videos, over the years we realized that there is predictive value if you understand what this data means. And what we're seeing here is a likelihood of that southeastern sunspot, the newest sunspot to rise in the southeastern limb of the sun, is probably going to be a significant sunspot. Why do I know that? Because I can see the acceleration here of the North Pole current sheet, sector boundary. So, here's the sector boundary, obviously where the red turns to green. That's the South Pole current sheet switching to a North Pole oriented current sheet. And it looks like it accelerates there a little bit. So that gives us some indication that the sunspot in the southern hemisphere there, the southeastern sunspot, will be more significant than the northeastern sunspots. Expect to see it rise and be very magnetically complex and maybe even grow today. Here's our line of sight field plot depicting the solar B field in blue, north solar polar field in green, south in red, and welcome to the south magnetic pole because you are in the south magnetic pole, although the north, again, the north pole, the north polarity current sheet sector boundary crossing is coming. And here's our line of sight coronal hole plot. You can see a bunch of red there, a bunch of south pole oriented coronal holes, and we see some north pole ones rotating in here also. So let's bring up the latest image here and see if we can polarize these coronal holes. So 2 in the east. Here's the last 24 hours in 211 angstroms. So yeah, we've got 2 north pole coronal holes over here. They're not too visible yet because, well, the corona is very bumpy. The rest of these are south pole oriented coronal holes, and the sector boundary crossing is somewhere like in there. So that's the situation for coronal holes, super important to the analysis of solar cycle progression. And we're going to move on to sunspots here in just a moment. First, how about a zoom in of that coronal hole? And of course, what's exciting about coronal holes is not only that they show us the solar cycle progression because they're depicting the magnetic field reversal process, but it also shows us where solar radio jets are located because those are sources of high-speed protons. And of course, coronal holes are fixated around the poles at solar minimum, and at solar maximum, they are transequatorial, many of them. Those are the most geo-effective type of coronal holes, as they can provide extremely high solar wind speeds and extremely strong magnetic fields, which can cause huge geomagnetic storms on Earth. So just as important as sunspots in terms of heliophysics are indeed coronal holes, at least in my opinion. And if you have any expertise in this field, let us know what you think. Do you think sunspots are more important, or do you think coronal holes are important, or do you think they're equally important? I think they're very similarly important. And check it out. It looks like a bunch of plasma gets splashed over that coronal hole there. It kind of gets dark. Oh, that just looked like some interference there. So that might have just been some kind of an effect from a flare or something like that. Sometimes a flare causes a contrasting problem, or it could have been just some limb darkening, essentially. It could have been some plasma splashing over the top of that. But in any case, a great view there of a coronal hole. And let's move on to sunspots next. Before we do that, let's pause for station identification. Welcome to the Smash News Network, least busted name in news. We're surprised that you realize that the channel exists. And thanks for leaving comments, Mike Bordages. Anyway, we're back to sunspots. And that's the current situation. Again, we'll have 2 more named groups likely. So 2 over here in the west, 1 up there, 1 down here, and also this new rising sunspot over here. I believe that will be the most magnetically complex one, and it looks like the Integrated Space Weather Analysis Center here agrees with me that the most likely place to see a major flare would be from number 3 here, sunspot 3234. It's certainly capable of producing an X-class flare, so don't be surprised for a second to see that. It could be happening as we stream. We're not sure. We'll let you know shortly. And I would bring us to the butterfly diagram next. So the butterfly diagram is kind of important in that, let's pick the biggest solar cycle on record, this one right here. And you'll notice that at the beginning of a solar cycle, you will see sunspots kind of at a certain latitude here, like around 40 degrees latitude. And then as the cycle progresses, you're going to see sunspots at a more varied series of locations. And then as it comes down, as we come off of solar max, you're going to see less sunspots at high latitudes and more sunspots at low latitudes. And of course, toward the end of the cycle, you'll generally only see sunspots right around the equator. So this is a feature that we've seen throughout solar cycle 25, seeing sunspots at drastically different latitudes, an indication of a healthy and rather normal solar sunspot cycle. It's not going to be below average. In fact, there's a high likelihood that it'll be above average. So Tamitha Skov already suggesting that solar cycle 25 will be a more significant solar cycle than solar cycle 23. A lot of people out there claiming solar cycle 25 will be weaker than 24. It's clearly already a stronger solar cycle. So stop with the conjecture. If you've painted yourself into a corner, just leave the corner. We don't care about the footprints, or let the paint dry if you like. Because it is not a grand solar minimum. Face the facts. Face the facts. And if your theory requires a grand solar minimum in order to come true, your theory is wrong also, because that's not a grand solar minimum. That's a lot of sunspots. People were calling for like 0 sunspots for the entire year of 2020 and things like that. And how did that work out? Of course, 2020 was not exactly an optimal year for obvious reasons. So there is just the SDO continuum without the 171 angstroms. Again, a couple new sunspot groups here showing up. It might actually be as many as 4 new sunspot groups, maybe even 5 new sunspot groups, but certainly 3 or 4. So we got a new one up here. We've got a new one down here. Another new one closer to the equator, I think. What's up with that? Anyway, at least 3 new named sunspot groups are very likely today. And let's take a look at energetic particles next, and it's flatlined. So we did see some significant proton events there. Not super huge ones or anything, but they did cause some polar radio blackouts. That has since subsided. Proton flux is flatlined. What's not flatlined is our red bubble shop. If you haven't checked it out, check out the links below the video. You'll find our red bubble shop with the products in order of best selling. So, and of course, we're constantly making some changes here. We're expecting to put out 3 new designs coming soon, maybe even today. So keep an eye on that. And when I say ion, well, pardon the pun. So continuing on here, today's featured product is our bestseller, Do Not Pole Vault the Caldera. And the reason we're featuring that today is because, well, we're missing some products. So we added some products to that, like the PET bowl, for example, and also the acrylic block. So one of my personal favorites is the acrylic block. It's just awesome. It's like a block of plastic that has the design printed in incredibly high quality. It comes in a 4x4 or a 6x6 acrylic block. And that is definitely on my list. One of these days, I might be a YouTuber that has a shelf behind me with a bunch of memorabilia from the channel. At the moment, I'm just standing in front of a green screen because I don't care about any of that crap. I care about the actual science and advancing the science of cosmology, as I have since the mid-90s. And if you're wondering how long I've been thinking about cosmology, it's since pre-1980. I'll just say pre-1980. In the meantime, do not pole vault the caldera. Our finest days lie ahead. Goes X-ray flux here, featuring, again, 2 M-class flares since yesterday. And let's take a look at some flares in 94 angstroms. So again, we've got another conflagration here of solar activity. We're seeing a ramp up as we've got 5 large sunspots already in the eastern limb. And again, to reiterate, I'm expecting the most significant one to be this one down here because of what I explained earlier about the heliospheric current sheet polarity. This is one of the many questions not asked that I got an answer to while doing space weather. So here's 131 angstroms, and we're going to show close-ups of that setting sunspot group, whatever it's called, 3234, I believe it is, in the northwest. Because again, we are expecting to see a possible X-class flare or maybe more M-class flaring events from that. The likelihood of it being involved in a coronal mass ejection that is earthly directed is dropping here as it is setting as we speak behind the northwestern limb. So we've got some extreme close-ups. First, the full disk zoom. And we actually had trouble getting this centered here because we've got sunspots at so many different latitudes, which again is an indication of a healthy solar cycle. Check it out. You'll see the Brian Keating filament here reorganizing as well, right in there. And we'll show you that filament here a little bit later in the video. it is still there, at least it was a half an hour ago. So here's an extreme close-up of just this setting group. We've got it in some additional wavelengths here. We've also added 304 angstroms ionized helium. Don't mind us, we just do the most comprehensive daily space weather in the known universe and the most detailed imagery of the closest star you'll see anywhere. Thanks again for stargazing with us. We've got a long way to go to complete this video. Here's 335 plus 211 angstroms. Just showing some different wavelengths here to mix it up a little bit. Two great M-class flares being depicted there. And let's move on to a star chart. So lots of talk right now in the astronomy community about planetary conjunctions, Saturn and Mercury, and you've also got Venus and Jupiter, which I don't know what that does to astrology forecasts, but I suspect it does something. If you want to see Saturn and Mercury, see them in the early morning. If you want to see Venus and Jupiter, see them in the early evening. Next, our solar system forecast. Welcome to 3/3/2023. We'll advance this 1 week to March 10th. Here's where things will be on the 10th. It's a very lonely side of the solar system here. As Earth speeds away from Mars, Mercury and Venus are indeed catching up. So here are some coronagraphs. And do we have any imagery from today yet? No imagery from today. So this is yesterday's imagery from George Mason University. And that Brian Keating filament eruption, not likely to be earthly directed, but let's take a greater view here from the perspective of Stereo A and the Soho-Lasco C3. So Stereo A depicted here on the left, Soho-Lasco C3 on the right. And let's move this forward to see the Brian Keating. DAG. I barely even see a CME. It looks like most of the material stayed. It must have been somewhere right around here. That's odd. Let's see what's going on with the Soho-Lasco C3. So 1938. Oh, we've got a pile of missing data there. Huh. All right. Let's take a look at our 24-hour coronagraphs. I still don't suspect that that's earthly directed. The likelihood of additional coronal mass ejections from the southeastern limb is still very, very high. Of course, we said 99 point bar 9%. I can't speak English today. 99 point bar 9%. Like a repeating decimal. Like it's a very high probability. So we've still got a massive filament out there, and you can see how much material is suspended out there on the eastern limb of the sun. Let's zoom in one level here. You can see all this plasma out here hanging out. That is because of a lot of sunspots over there. So exciting stuff continues to happen during solar cycle 25. If you thought the sun was shutting down, think again. And if you're frightened of space, I feel sorry for you. There is great science to be done in the realm of cosmology and astrophysics because it essentially is a laboratory that we don't have on planet Earth. There are things happening in space that we can't really simulate. And lots of things in space are jumping up and down and saying, hey, look at me. I'm going to teach you something about physics. It's up to you whether or not you can figure out the reality of what is going on there. So that's, of course, the exciting thing about cosmology in general. You got to work on things backwards and forwards, right? You got to look at things on the largest scale and on the smallest scale if you expect to understand the physics. There are many chicken and egg arguments when it comes to what is causing solar activity and so on. Once again, you're invited to become a member of the Smash team at the gold level. if you want to hear a plausible hypothesis as to what underlies these solar sunspot cycles. It's pretty serious, and when the paper passes peer review, it'll just be the most important paper in hundreds of years. No big deal. Moving on to filaments. And check it out. We're going to see the Brian Keating filament here. There it is. Check it out. It's still there. How do you like that? We named it when it was down here because I could see that it was going to erupt. And whoosh, part of it erupted and part of it splashed back down. So that's just awesome. Not quite as awesome as the Tamitha Skov filament, which actually caused a KP7 event. So we're having great psychic powers here in terms of naming solar filaments. Somebody even named one after me that caused an Earth-directed CME, I think. So that's always exciting. And again, if you're frightened of CMEs, I don't know why, because the sun's not going to kill you. So anyway, lots of filaments indeed, dozens of them on the Earth-facing portion of the solar disk. If you want to name filaments, just type in the hashtag #NameThatFilament on Twitter and join us over there. You are invited. And if you don't have a Twitter account, why not get one? I mean, the shadow bans are still certainly in effect, and it's very obvious. You can tell easily which accounts are shadow banned just by looking at their interactions and their actual views, because Twitter is foolish enough to show you that information. And of course, Elon was foolish enough to show you that shadow bans are a thing. He just didn't remove the shadow bans. So for everybody who thinks Elon has restored free speech to the internet, think again. Twitter censorship still exists. Elon just thinks that his fascist censorship is better than the previous management's fascist censorship. Now that I got that out of my system, let's continue on to once again invite you to join us over on Twitter. So we're all over the internet at smashomash.com, and you can find links there and so on. So join us on Twitter. Here's the past 24 hours in 193 angstroms, a wavelength we don't show all that often. It's great that it shows the extended corona, and you can see how much material is out there suspended by those coronal magnetic fields over on the eastern limb. That's a lot of material, so look for additional coronal mass ejections to remain nearly as likely as they were yesterday, maybe only 99.9%. So that was the last 24 hours. Here is the last couple of hours, and we've got another CME event happening as we stream the video. So there out of the southwestern limb, you can see some material. It looks like it's exiting. Most of it's exiting. Some of it's probably splashing back down, but most of it's exiting, it certainly looks like. So that'll be something to look at later today. Kind of unlikely that it'll be earthly directed with the location of it there, but you never know. These things can be swung drastically. In fact, we've seen Earth-directed coronal mass ejections that come from an invisible opposite side of the sun. So, we've seen this many times on the channel, and this is the way it works. We prefer to immerse ourselves in the data, because what happens is you end up with answers to questions not asked. So in science, we ask questions, and sometimes we get answers to the questions, but more often we end up with more questions and answers to questions not asked. So when that happens, you just have to go with it and see where it takes you. And often it takes you to some very interesting places indeed. This brings us to our bonus features segment, starting out with satellite charging hazards. So before we get to that, don't forget to visit the links below the video. If you're in the market for any CBDs, head to hemplucid.com and make sure you use the promo code SMASHOMASH on checkout to save some cash. Yeah, save some cash with the promo code SMASHOMASH. Also, you can use our link below the video to shop. That'll save you some cash too. Thanks to everybody who's picked up products, and thanks to Hemp Lucid, our latest and perhaps our greatest affiliate/sponsor. Links below the video and on the homepage at smashomash.com, the official homepage of the Smash News Network. Least busted name in news. We saw a niche when it came to space weather, and rather than be word about space weather, we decided to create content instead of making suggestions to hacky channels that can't get out of their own way. So anyway, welcome to the Neo-Renaissance. If you can't help us out with some sort of monetary contributions to the channel, then why not help us out with clicks by visiting smashomash.com and hit us up on social media, tag us, etc. We are interested in what you're doing online, so drop us a line. Satellite charging hazards showing up here. Some surface charging hazards, significant ones over the Central Pacific. That's caused by low energy electrons that build up on the surfaces of satellites, hence the term surface charging. Here's the GOES electron flux here. That's the past 3 days. And I believe we're going to be just about reaching into electron storm levels again, electron warning levels once again. If you're new to the channel, these N's and M's give you insight into the location of the satellites. That is noon local time for the GOES 18, for example. That red N right there, that's noon local time for the GOES 18. And then the M is midnight local time for the GOES 18. Here's the NOAA forecast for the electron flux, expecting a dip. And, oh, that's right. I would tend to agree because, again, we have a coronal hole high-speed stream showing up here. So we may see this dip in the electron flux. I would tend to agree with this forecast. Here's the one-year graph to put it in context. That's from solon.info if you want to check it out yourself. Solon.info is great. It shows coronal holes. There's an archive of coronal holes going back quite a few years there. I'm not exactly sure how far. It'll tell you recurring coronal holes that have gone all the way around and come back. Let's take a look at the F layer, the ionosphere next. That's where the electron flux is measured by the GOES 16 and GOES 18. Feel free to pause the video on this frame if you're not familiar with things like the penetration of electromagnetic radiation into Earth's atmospheric layers. So here's the previous day in vibrational frequency, the ionogram, courtesy of Australian Government Bureau Meteorology. We show it daily on the channel, even if I don't have a comment on it, because it's creating a log going back half a decade about the ionosphere, which means we can pull data just by simply watching the old videos on our YouTube channel. Yeah, because there's actual value, predictive value, and actual science occurring on our channel. So that's part of the reason why it's done. Now, the anomalygram shows anomaly in megahertz from a 30-day median, and of course, our regular viewers are well aware of the South Atlantic anomaly, which is right over the sort of the middle of the South American continent, right about there. A great image there. And we have seen some migration of this, possibly additional South Pacific anomalies forming, as we do see indications up here. So this has been a strange area in the past couple of months, and if you've been watching our channel, and you are well aware of this. Anyway, let's bring up the latest image. That's 1315 universal time ionogram and 1315 universal time anomalygram, anomaly in megahertz from the 30-day median. We'll also show the total electron content, which will show you the most likely places for GPS errors. Your GPS satellite's at about 12,500 miles of altitude. And here are the free electrons in between it and your handset. So you can expect this to get a little jiggy here. We do typically see more anomalous electron contents when we see coronal hole high-speed streams and coronal mass ejection impacts. Keep in mind, this is the free electrons all the way from the inner portion of the outer Van Allen belt through the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. So that's several different layers there. That's why it's the total electron content. It's the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. So a little bit of abnormalities happening there in the electron content, as is typical of a coronal hole high-speed stream. And let's close out the space weather section of the video with the latest intensitygram and latest colorized magnetogram. Again, I think this sunspot down here is going to be quite significant. What the hell? What is up with that? All right. Anyway, there it is. And at the moment, it's not looking significant at all. It looks like an alpha class sunspot. So we've got 2 South Pole oriented umbrae there, or maybe one separated by a light bridge, but I don't see any North Pole umbrae there. That is currently only an alpha class sunspot, but there may be larger spots behind it, or who knows. So it's too early to tell. It's not risen yet. Here's your full disk rockback. Let's take one more look at this beast. Wow, it is certainly beta gamma delta class. That is beta gamma delta class all day, and that leading umbra there is like 2 to 3 times the diameter of Earth. So that is a decent sunspot, and indeed, the likelihood of large flares is there. So we'll probably have this group named. This group down here will probably get a name today, and of course this group will certainly get a name today. At least 3 more named groups are likely. Also possibly one here right near the equator. So lots of stuff going on, as always. Solar Cycle 25, not disappointing. And let's get to weather. So here's our meteorology segment. And here at the Smash News Network, Least Busted Name and News, we used to separate these videos and make them, obviously, separate. And thanks for leaving a comment, Cookie Spacey. Yes, the grand solar minimum is dogma, not science. They're relying on one paper and denying all the observations that we currently see. So there's 0 chance of a grand solar minimum in most of our educated guess opinions. And I don't know what's up with it. They would rather be right and win the argument than cite facts. Anyway, they'll probably look at this section and go, see, that's proof it's really cold in Antarctica. Check it out. It's really cold in Antarctica. So it's summertime down there, and it's currently 74.8 degrees below 0 Fahrenheit. Negative 74.8 degrees. Summertime in Antarctica. It's not exactly a warm summer. That could be some kind of a record-breaking temperature, folks, because that's the coldest place in the world. All right? It's summer down there. So, yeah. Oh, it's only 66.7 degrees below 0 Fahrenheit there. So yeah, that's on the cool side, you could say. And of course, if you want to go to Antarctica, it'll probably be almost impossible to go in the wintertime. It'll cost you about 40 grand, I believe, to visit Antarctica. It's definitely on my bucket list. When the channel grows a bit, perhaps we'll do it as a project for the channel. Yeah, it's certainly on my bucket list to hit up Antarctica. Anyway, let's take a look at the winds here. These are the surface winds of the eastern world. Here are the jet streams of the eastern world as we transition into the realm of meteorology. More actual science depicted on the channel. More actual science, not weather or climate nonsense or alarmism, just facts. Here are the jet streams of the west. We've got a doubled up jet stream over the western North American continent. And southern jet stream there, a little incoherent, especially around the equatorial South America. These are the surface winds of this side of the planet. We've got 2 strong lows there in the North Atlantic and a strong onshore wind on the Gulf of Mexico. Here are the surface winds of the central world. And these are the jet streams. The jet streams being the single most predictive factor if you needed to look at only one weather signal to forecast global weather patterns. The jet stream would be my pick. Let us know what your pick would be if you've got other ideas in the comments. Next, we're looking at clouds and fog here, and check out the rapid cloud nucleation over whatever country that is. I have no idea. My knowledge of African and South American countries is pretty pathetic. My South American and African geography are not my strong points. Anyway, that's clouds and fog over the Americas. It's too dark to use the visible satellite for most of that imagery there, so we're using the 3.9 nanometer radiation. Croissant Earth, depicted by the Interactive Weather Satellite Suite. Next, our weather.gov map, and there are a lot of warnings. If your location's lit, click your location on weather.gov. That's a little bit too many counties for us to explain. However, we did scroll down and show you the key. So if you need to pause the video on this frame, feel free. The beauty of video on demand is that you don't need to attend our live premieres. Although keep in mind that I'm not only Smash-O-Mash, I'm also a client. Weather.gov is the location of those warnings. We've got some major flood warnings here. So let's take a look at total accumulated precipitation for the next 3 days based on the 72-hour GFS forecast model. Southern Illinois expecting like 5 inches of rain there. So yeah, that's your total accumulated precipitation in inches based on the GFS 72-hour forecast model. Also, Northern California getting some extreme precipitation. The Pacific Northwest in general is soaked. And let's take a look at snow accumulation next, since a lot of that precipitation will be in the form of snow. And another 2 to 3 feet forecasted for large sections of eastern California. Also some more snow coming to the Pennsylvania, at least according to the GFS 72-hour forecast model. We'll also show you pressure and precipitation. So we've got some extreme weather here happening right now. And a strong low has formed near the Arkansas-Missouri border and is steadily moving to the northeast. That's your 72-hour GFS pressure and precipitation forecast. More ice on the way. Pennsylvania and New York are going to get plastered with some significant icing there. Also parts of New England. So here's your pressure map. This is windy.com. By the way, they got a great mobile app if you've never checked it out, windy.com. It's free. And right there near the Tennessee, Missouri, Arkansas border there is the current location of that low, and it is certainly causing some significant weather. We'll show you the radar here in a moment. First, our lightning mapper, and strong lightning storms there over Texas and Oklahoma over the past 10 hours. Dag. And here's the current situation. If you're in the path of these storms, be prepared for that because there could be some quite severe weather here. So right now we've got active cells here near Dyersburg and Blytheville. By the way, that's lightningmaps.org. Next time you hear thunder, check that out. If you're new to the channel, you may have never heard of it. Lightningmaps.org, your real-time lightning map source. Also, Louisville. Looks like things have calmed down there a little bit, but those storms are going to continue to be strong all the way to the Great Lakes and beyond. So they're going to bring quite a bit of weather here as they move to the northeast. And here's your U.S. Doppler radar map. There's the full 50 states view. Some precipitation there around Hawaii and Alaska. We'll focus on the lower 48. Let's briefly zoom in on that system. So the heaviest precipitation is actually ahead of this system. I suspect there's some dry massive air down here. We'll take a look at that in a minute. First, shortwave radiation depicting clouds and fog. So that dry massive air to the south of that system is preventing its counterclockwise rotation. And you can indeed see this impulse down here. This is a great example of high pressure air, giving that a boost, pushing it up to the northeast in a very consistent pattern. It'll be a very predictable system there. As long as that dry massive air, that essentially that high pressure system continues pushing that up to the northeast, you can expect it to be fairly predictable. Here's a recap. U.S. Doppler radar. Clouds and fog at 3.9 nanometer infrared radiation. As NASA projects a croissant-shaped Earth onto a fake Adobe spherical globe. Earth, it's not flat, it's croissant-shaped. What are you, an idiot? And there is water vapor. That should give you some definitive info indeed. Hopefully we gave you a lot of definitive info indeed. Thanks for tuning into the Smash News Network, least busted name in news. Congratulations on realizing the channel exists. In the meantime, I'll have been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back. Please visit the links here and here. And don't forget to subscribe up here. And we'll see you soon.